Hello there. In this video, we're going to talk about multiplying algebraic expressions together. This is also called multiplying polynomials together. But I'm going to steer clear of that word polynomial for now. That's going to come in a later video when I deal with polynomials more in depth. What we're dealing with here is really we're multiplying two algebraic expressions together. And the big question becomes, how do we handle this? Because like we've discussed in our combining like terms videos, we can't combine these together. We can't combine these together. This is 3 lengths of x minus 2 units. And this is 4 lengths of x plus 1. So what I'm going to do in my usual fashion is I'm going to show you how I learned it. And then I'm going to show you what I feel like is a better way of doing this type of problem. Okay? So what I learned in my school was the FOIL method, or what is called the double distribution. FOIL is the tool we use, but we're using the distribution property and we're using it twice. We got to distribute this 3x to both the 4x and the 1. That's one distribution. And then the second distribution is we got to distribute this 2 to the 4 and the 1. Okay? Now, FOIL becomes the, I think, acronym, if I'm using that word correctly. We multiply the first terms together. We multiply the outer terms together, we multiply the inner terms together, and then the last terms together. Okay, so the first, that would be 3x times 4x. So I'll write that out. 3x times 4x. I'll write it all out and then we'll simplify it as we go. So that's a check. Now, in between each sets of terms that we're multiplying, we get a plus sign. Not every answer will end with a plus sign, but we may simplify it along the way. So the outer terms would refer to the 3x and then the 1. So this would be 3x times 1, and then I'll put another plus sign. So that's the outer. The inner terms would be the negative 2. So I'll multiply it by negative 2 and the 4x. So those are the inner terms. And then the last terms, I'll put the plus. The last terms would be the negative 2 times the 1. And now all we have to do, we've got our final answer set up, we just got to simplify anything. So 3x times 4x, well, 3 times 4 is 12, and then x times itself is just itself squared. Put my plus, then I got 3x times 1. Anything times 1 is itself, so that's 3x. Now, here I notice I've got the negative, so plus and negative will always result in a minus, and I don't have a negative here that would cancel out with it, so minus it goes. 2 times 4 is 8x, and then again, we got a plus a negative, so another minus. 2 times 1 is 2. Now, we're not quite done. We have one last step to go, and that's to simplify these two middle terms. We want to look for wherever we see the terms we can combine. And when you have a problem set up like this, it'll always be these two middle terms. So 12x squared, that doesn't get combined with anything. And remember, what we have here is a positive 3 minus an 8. So off to the side, 3 minus 8, that would be negative 5. So this would be a minus 5x, and then 2 can't combine with anything. And we're done. Now, there's nothing wrong with that method. I grew up with that method. It's how I've done most multiplication problems of this nature. But I wanted to bring your attention to another method. And this we will tie in geometry. Say we have something, we call this L. And I'm choosing that for a reason. And say we call this something else, we'll call it W. So I have L times W. The reason why I chose these is because it reminds us of the area of a rectangle. Area of a rectangle equals length times width. So what we can do is represent a rectangle. I'll just put L at the top and W off to the side. But remember, L is equal to 3x minus 2. And W equals 4x plus 1. Now, does this help me get any closer to solving it? In a way it does, because what I can do is I don't know how I would multiply 3x minus 2 times 4x plus 1, but what I do know is how to multiply 3x times 4x. So what I'm going to do is I'm going to erase this, and I'm going to write it as 3x, and then I'm going to draw a line, because I still had that minus 2. So what this is a dimension of 3x, and this is a dimension of negative 2. And then you probably guessed it, I'm going to go ahead and set this up in a similar manner. I'm going to do 4x up here. I'm going to do a plus 1 down here, or you can just write 1. And so what we're doing is finding the area of each individual rectangle. So if this was a rectangle with dimensions 3x by 4x, I would find the area by multiplying these two together. This would be 12x squared. 3 times 4 is 12, and x times x is x squared. Now over here I have a rectangle with dimensions 4x and negative 2. Of course we can't have rectangles as lengths negative, but we're working through a problem. This isn't an actual rectangle. So 4x times negative 2, that'd be 4 times negative 2 is negative 8x. Here we have a rectangle with dimension 3x and then 1. 3 times 1 is just 3, and then don't forget the x. And then here we have a rectangle dimension negative 2, positive 1, so that multiplied together would be negative 2. Now, great, we found the area of 4 little rectangles, but what's the area of this big rectangle? That's what we ultimately want to find. Well, the area of this big rectangle would just be the sum of these smaller rectangles. So 12x squared plus a negative 8x plus 3x plus a negative 2. And now we can work on simplifying. This is where we have to rely on our combining like terms. We have the negative 8 plus 3. That's just negative 5. So 12x squared minus 5x plus a negative 2 would be minus 2. And look, we got the same answer as before. And we have to know when to stop combining like terms. So now, which method do you choose? Well, once again, you have to take agency of your own learning, and you have to decide which of these methods did you understand the best. I'm going to tell you which method I prefer, and if I need it in the future, this is the method I'm going to prefer, and that is the rectangular way. And I'll show you why in another example. So my last example is 5x squared minus x plus 2 times 3x cubed minus 2x squared plus 4x plus 1. Really quickly, if you wanted to use the quote-unquote FOIL method, you could. But FOIL won't help you anymore because you've got more than 4 terms. You've got to have to take this and multiply by this, 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 and this. Then you got to take this and multiply by this, 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 and this. Then you got to do this and multiply by this, 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 and this. Not only does the rectangular model help with all that, it helps consolidate everything to make it much nicer and neater. So that's what I'm going to do on this problem. I usually do this first one as my top one, so that's 5x squared. I'll do the minus x and then the plus 2, and then I'll start creating like a table. Okay, and then this one I will put vertically, so 3x cubed, and I'll draw a line, negative 2x squared, and then draw a line, and then I get 4x, and then I get 1. And now we can remind ourselves this is all the operations. If we do the quote-unquote double distribution method, again, it's not double this time because it's more like triple, but if we do it, this helps us remind ourselves of all the multiplications we have to do. So 3 times 5 is 15. Now x cubed times x squared, from our properties of exponents videos, this would be x to the 5th. Now we do 3 times what is essentially a negative 1, so that's negative 3. X cubed times x, that would be x to the 4th. And 3 times 2, that's 6. And then we just have the x cubed left over. Negative 2 times 5, that's negative 10. And I might speed up a little bit now. Feel free to... combine like terms. True, but when you write it out in this fashion, and assuming you set it up correctly, the terms you can combine are always in the diagonals. And so this helps consolidate that work. So we got negative 10 plus negative 3, that'd be negative 13x to the fourth. 20 plus 2 plus 6, that'd be 22 plus 6 is 28x cubed, and I forgot to circle 1. There we go. We got 5 plus a negative 4, that's 1, plus another negative 4, that's negative 3x squared, and then negative 1 plus 8, that's 7x. So in writing our final answer, we start up here with the 15x to the fifth, and then we go through our diagonals. Negative minus 13x to the fourth. Sorry, I meant adding a negative becomes a minus. And then we got 28, so plus 28x cubed. And then we got minus 3x squared plus 7x plus 2, and we're done. If you like this video, feel free to subscribe and like, and leave a comment below if you'd like to see more problems like this in the future. Thank you for watching.